And we're live. Hi, everyone. Welcome to this week's Inside.net. My name is Cecil Phillip. And if this is the first time that y'all are joining us, welcome. What we try to do is have conversations with folks that are in the .NET community, folks that are building really cool and interesting projects, and just kind of learn a little bit about what they're doing and how we can get involved in them. And so I'm really excited today because today we're featuring a project that I feel like I've been looking at from the side for a long time. And I've really been wanting to learn more about it. How does it work? And how it can really help .NET developers build distributed applications. And that project happens to be MassTransit. And so today we have Dru Sellers, our friend here. This way. There we go. Pointing the wrong way. Dru's here. He's going to talk to us about MassTransit. Dru works on the project a little bit. And actually, why don't I just let him tell you guys? So Dru, why don't you give yourself a little bit of an introduction, tell folks who you are and what do you do?
Thank you. My name is Dru Sellers, and one of the founders and part-time contributor to the project, which is MassTransit, which is you can think of it as like ASP.NET for messaging is probably the most succinct way to explain it, and specifically how that lets you build distributed systems. So that's the project in a nutshell. It spun out of myself and co-founder and main contributor of the project, Chris Patterson. We both had this need, and we kind of met each other at the same time of having this need of needing to build a distributed application at our respective places of employment.
So I always love a good origin story. You know what I mean? So we're not going to go all the way back, but I would love to know, like, how did you get involved in building distributed systems in the first place? Like, is this just like an interest you had, or was it something that like grew out of like a need that you had? Or was it just, hey, I did it at work and it was cool and I just kind of kept doing it?
I had a really specific need at where I worked. So at this time, I was working at a place called the Federal Home Loan Bank of Topeka, and we were trying to integrate the loan origination process with the credit underwriting process, while also getting that data into a then being built data warehouse. So the tools that we had at the time would have been like SSIS, like early days SSIS.
Mm-hmm.
And we had a very specific issue, which was that those were not very source controllable. It was XML. The XML contained the UI display information. So if you change nothing but just move something around, you'd get this big diff.
Mm-hmm.
So we kind of were looking for something else. As I was scouring the community, I started to hear about this thing called an enterprise service bus. And from there, I personally learned through reading. So this was, let's see, we're in 2023. So this is like 2007 at this point. So books would have been the main choice. And I found the classic enterprise integration patterns by Gregor Hoppe.
Mm-hmm.
And that's where I started to kind of tear into it and started to learn about it. And then later next year is when I met Chris at a conference called alt.net in Austin, Texas. And we were just kind of commiserating on the same problems. And like anything else in open source, it's a very social construct.
Yeah.
And we cracked open Google Code and made a Subversion repo and started contributing. And I believe the first commit is literally like December 25th, 2009 because what else are we going to do?
So on Christmas Day, December 25th, you're like, I've already eaten my food. We've hung out with the family. I'm just going to sit down on the laptop and why not? Let's give it a shot. And see what's going on. I love it. It's funny because I spent most of my career, I still spend most of my career building like backend systems, and particularly systems around like HTTP and web things. And I always like to say every web developer in some way or the other is like a distributed systems developer. But they really, most of us don't really look at it that way, but at least that's the perspective I choose to have. Because it's not the days where, and I'm going to date myself, but like the days where, your server could be under your table and like the database and the web server and everything is like on the same box. And now like your method of distribution is really like inter-process calls versus like I'm hopping over the network or I'm going somewhere else, right? Like hopefully for most of you, that's not the reality that we live in today. And so I think for folks that are building web applications, we have to think about things like, load balancing, we think about proxying, we think about message translation, right? Like I send it in this format, but like these backend systems need it in another format. I have to change the shape of the payload. I need to do off, and like all these other cross-cutting concerns have to apply to like that message, right? And then we kind of get into the concept of, or the conversation of, well, what is a message, right? Like what does it look like and how's it shaped? Like what's the metadata and like what's the business data that's attached to? What's the format we're sending it in? And it just, I don't know, it just kind of feels like such an interesting topic to like really dive deep into. And so I just, I kind of just went down the rabbit hole, right? And I feel like I'm keep going down the rabbit hole of finding like really cool, interesting projects in the .NET space, like MassTransit, that allow us as developers to kind of like play in that space a little bit more. Before we really dive into MassTransit, I think it'll be fun if we have a conversation a little bit about like what are some of like the core tenants or the core components that you think make up a distributed system, right? Like I don't know if you have a thing that's like you have a distributed system if, right? Or your distributed systems framework needs to do like these things. Like where does your head go when you think about like those type of things?
I mean, you're definitely, I think the maybe not helpful but very true realization is if you have a distributed system, if you're having to communicate with another process. So if you have a database and you have an application, it's distributed. Like at its core, you now have a distributed system. Even more so if you're talking to two different, like if you have to talk to two different databases and you start to run into transactional issues, like I can't maintain a transaction across these two databases, because maybe you're talking to SQL Server and Postgres or SQL Server and Oracle. You really, really have a distributed system then. But I think in the way that we conceptualize it today, it is much more, if you have one app talking to another app, then that business process is distributed because it has to cross multiple boundaries. And right. I do think the key thing here is the process boundary, because everything that we do with MassTransit, everything that we're doing is accounting for failure. When this fails, how do I handle it? And an HTTP call, if it fails, you're going to get a 500. You're going to get some kind of a response that tells you that it failed, maybe. Because if you're behind a proxy, now you're distributed, because maybe the proxy terminates your HTTP request at 1 minute because that was the setting that ops did, but the request still completes on the backend service. It tries to give you an HTTP 200, but it can't because the proxy's blocking it. It's not going to let it out. Yeah. And so now your app has to try again. And so, bam, we're in distributed systems. We're in the problem where like the fallacies of distributed computing are going to start showing up.
Right. Yeah. When you talk about the fallacies of distributed systems, the first thing that I always think about, and again, for web developers, this is probably one of the first things that y'all think about too, is the network is always unreliable, right? Like I can't trust the network. We want to, but you really can't, right? Because kind of like what Dru was just telling. What happens if, I don't know, someone pulls the plug on the server? What happens if there's like a blip in the network, right? And like just in that moment, you're sending a message there, you lost connectivity for like a millisecond, right? But that causes your application to crash or shut down. And then how do you handle those errors? How do you retry those errors? And I think even deeper than that, like how do I retry those errors while not redoing the work, right? Because I don't, let's say, hey, I want to check out from my shopping cart. Shopping carts is, example people always use. And okay, I've already charged this customer, but network failed me. I can do it again. I don't want to charge that customer twice or 3 times or 4 times, as many times as I have to retry. They're probably not going to want to do business with us anymore, right? Yeah. And so now we have to think about how could we like reliably run these types of workflows, so to speak, to make sure that like, our application is working the way that we need it to work.
And I want to add on one other little flavor point here, which is one of humanity, which is, as a developer, I want to be able to provide my operations team a little bit of grace so that they don't have to maintain the network uptime at a gajillion %, right? Like, how can I buy my operation team, who is my compatriot, you know, in the war of IT, you know, they're in the trenches with me. How can I give them like just a little bit of grace to bring the network down, to do updates, and to not have to go spend millions of dollars on like really fancy stuff because my app simply requires 100% uptime? Like, I think that's another really interesting approach to thinking about distributed systems, is because they can oftentimes tolerate failure and failure in the network connectivity. We can give our database team the breather it needs to do an update.
Right. So if I look at it like this, I think some of the things that, if you decided to build a distributed application, which is probably a lot of us, some of the things that you really need to think about is, well, how do I, like the messaging, and we spoke about that for like 10 seconds. We want to think about, well, how do I handle errors? How can I be resilient in the face of failure, right? I think the observability aspect is also another important thing, right? Like, how do I know what's happening in my system? How do I know where is it going? And how do I know the amount of hops that I'm taking to get something complete? How do I know what's happening in those different places? And I think another thing that we probably want to talk about, maybe in terms of like your actual framework, is, well, how can we test these things, right? And how scalable this thing is going to be, like, under load. You know what I mean?
Yeah. So we definitely need to do all of those things at the very top, because these two systems are talking to each other. We have to agree on what we're saying, right?
Yeah.
So programming, in the end, is sometimes called a context-free grammar. Like, there's no context. This is a this and that is a that, and 'twas always thus. Until somebody starts to put the wrong data in the wrong field because it matches the type, right? Like, it was a string. It said a date. I did it YYYMMDD, no slashes. Yeah. Bro, it's DDMMYYYY with dashes. Like, little things like that can cause hiccups. And so being able to, when you're building these distributed systems, having a way to agree on those semantics. And so one of the first things that we did in MassTransit is we started with, we're going to do strong type messages. So a lot of the things that, so everything is like, every message is a class. So when you ask, what is a message? Like, if you're reading the literature, a message is just, it's a data payload. It's an uninteresting answer. You're like, great, it's bytes on the network. But as a .NET developer, it was super handy to start to explain to people that you just make a class. We're going to serialize it using the serialization technology, and it'll flow across, it'll deserialize. And over time, those serialization tools have gotten more and more powerful, where you can, instead of sending a date time across, you could have a corporate date time standard format class that has a JSON serializer on it that then makes sure that the date times are always passed through the right way. Or it's, or from a networking perspective, the receiver can be a little more lenient on what it receives, but we try to be very strict in what we output. But so at the core element of MassTransit is, it's defining those contracts. And MassTransit does it with .NET classes, which means that you are ultimately sharing an assembly across projects.
Right.
You don't have to. You can copy paste the code if you want. But in practice, just share the assembly. It's significantly easier.
So this is how I could pick out, like, real, maybe that's not a good thing to say, but this is how I could tell that folks are really, like, distributed systems nerds, is when we could spend like hours talking about, like, the message shape. Right. And one thing I wanted to ask you about, as you were bringing that up just now, like, what are your personal thoughts on, like, messaging formats and, like, supporting those different messaging formats? So as an example, like, everyone uses JSON. JSON is almost like the default that a lot of folks use. But then there are, particularly if you're just talking about not necessarily going over the web, but just going, like, over like a TCP channel or some other thing that's not HTTP, a lot of folks might want to use, like, some type of binary format, right? Like, gRPC uses again, like protobufs. And I've heard about this thing called Avro. Never used Avro, but I've heard a lot of folks use that. And, I'm sure there's folks that still use XML and some of these other types of things. And I think Orleans, if folks are familiar with Microsoft, Orleans has its own specialized formatter for like serializing text that go over the back and forth over the wire. So I'm curious to hear like what are your feelings on like not just serialization technology, but like the format that actually goes over the wire and like use cases of when you might want to use a different one or maybe even multiple ones in the same application.
So I definitely am a fan of JSON first. So barring a specific business need, I would recommend using JSON. The reason that I do so is there is everybody's editor can format JSON. Like I can copy the message, paste it into my editor, and I can format it, and I can get to work. It's not a specific everybody, especially at this point, the broad generalized understanding of the entire developer base, their ability to understand JSON, to write JSON, to format JSON, I think is a huge advantage. Now, at some point, there may be a performance need, a business need to switch away from JSON. And to that degree, MassTransit supports a variety and has a pluggable serializer. So if you need to move away from the MassTransit specific one, which includes an envelope, we have a way to just do raw JSON. If you need XML, you could plug in XML. If you need YAML, you could plug in YAML. We'd have a little bit of support for protocol buffers, but the .NET is currently going through a bit of a churning phase with its support of protocol buffers as the ASP.NET team really starts to embrace it based on the needs of Azure, because their scale is so high, and they need to distribute their protocol buffers definitions to multiple teams. I do think we'll see like a shift in the .NET support of it where it becomes a lot easier than it is today. So all those things are possible. But again, personally, if I was advising somebody, I would only move away from JSON if there was like a strict business requirement, not because it's faster.
Yeah. I think one of the things that we get from JSON itself, kind of like you said, like the interoperability of JSON is easier, right? And if for whatever reason you're building a system that's using like multiple programming languages, right? That have to like peek into the message or peek into that queue or whatever it is that your endpoint happens to be, then it's easier from the perspective of, I feel like we're at a point that like most programming stacks support JSON out of the box. And then also too, it's human readable, right? So like you said, I could copy paste and I could look at it and I could be like, oh, it's missing properties, or I'm not missing properties, or the data in this property is invalid and failed my validation, which is why I'm getting errors, right? Like the debuggability of JSON, I suppose, is like pretty easy cross languages, right? Which I think makes it a really good choice.
And we have a ton of tooling. Like we have JPath or JS path. So like we have a language for saying, I want to specify this path inside of the JSON. We don't necessarily have that for a bunch of other of the format choices. I can pipe the output into a command line tool called JQ. JQ will then render, format it. It'll let me select it. I can throw it through some bash scripting. So again, it's just that the malleableness of it. And it's because it was early, because it was one of the first, right? It's had a lot of time and the community has just blossomed around it. And so it is now, like, because of that, a de facto standard. Is it the best? Probably not. But there's no weirdness points for it. If I bring you onto my team and I say we're using JSON, you don't even bat an eye. If I say we're using Avro, you're like, let me go read about Avro.
Okay, we talked to my security team about this. Like, I got to talk to people about this thing before I just say yes to you.
Yeah. So I'm always trying to be aware of like, where am I spending my weird points in an application that I'm building? And I just try to be really conscious of it. So yeah, this is a general theme, but that's my thoughts on serialization.
Got it. We have one question that's coming in from LinkedIn. And I want to make sure we don't take too long to answer it. So Samuel from LinkedIn is asking, how different is MassTransit from the existing messaging services in Azure? And also at the core of MassTransit, what technologies were used? So I guess it's more of a, you know, is mass transit different from M Service Bus and Event Hub and those other things? And I'll let you go ahead and answer that, Drew.
Yeah, so with that specific question, the first thing I would do is let's draw the clarity between Mass Transit and Azure Service Bus. So Azure Service Bus is what we call a broker or a transport. It is a way messages get communicated over Azure Service Bus. A direct competitor to Azure Service Bus would be like RabbitMQ or ActiveMQ. There's some other like more niche ones, but those are kind of like your main competitors, and they all perform roughly the same activity. SQS is the other largely big one for Amazon, in that they maintain queue semantics. So it's a queue data structure that's available over a network. And that's what that does. So Mass Transit sits on top of these things. And Mass Transit provides things like parallelism, the ability to have 10 workers working off of a queue at a time. So we enable like competing consumer. We handle retries, we handle failures, we handle serialization. In some degrees, we can handle persistence. So we really sit on top of those frameworks. And as far as what is Mass Transit built out of, it's a .NET app. It's a .NET library that you then build your application on top of. And again, if you're familiar with what ASP.NET does for sitting on top of a TCP queue and providing you HTTP semantics, Mass Transit sits on top of that same TCP queue, but on top of like talking to RabbitMQ, not an HTTP protocol, the AMQP protocol, and gives you a lot of the same stuff where you can say like, hey, I want to write a response back to this person using HTTP. Mass Transit will do the same thing. I want to write a response back using AMQP. I want to have serialization standardized on my HTTP stack. You can have serialization standardized on your AMQP stack. So Mass Transit, ASP.NET Core, very, very, very similar. And then we sit across all of these different brokers. So a really powerful mechanism is you can be developing locally on RabbitMQ so that you don't have to have a network connection because you're on a plane. And then you could deploy to production using Azure Service Bus. And because you're programming to R primitives, you'll flow right across.
So the way that I kind of look at it is Mass Transit is like a messaging abstraction that sits on top of these other implementations, and those implementations, Samuel, might be Azure, Service Bus or SQS or something local on something in memory, right? But like the fact, like kind of like what Drew was saying, like you have like a consistent API that you could use. So as I'm thinking about, hey, maybe I want to like try out a couple of different things, like I can swap the implementation without like shuffling around my code too much. I could swap the implementation without adding new NuGet packages and different APIs and having to DI another thing, right? Like there's not a lot of churn if I need to switch the implementation. I think at that point now it's a conversation with your operations team, right? Mm-hmm. To be like, okay, well, what are we deploying and how do we secure it and what are those credentials and how how do I go from like local to production using like a different thing at the bottom, right?
Exactly.
So, Samuel, hopefully that answers your question. If you have any more questions, if anyone else has any more questions, feel free to kind of drop in and let us know. I think this is a good point for us to kind of hold on one second. So Samuel has another question. I'm going to pull this up super quick. He's asking, what was the biggest challenge they faced when developing Mass Transit? So I guess they is you and Chris.
Yeah, that works. Oh man. So originally the biggest challenge. Okay, so we had serialization out of the box. Like we already had Newtonsoft at this time. So we were pretty comfortable there. .NET had really great support for XML serialization from the get-go. So that was never a problem. Chris is specifically very comfortable with multi-threaded work and all of that. So that was never really a challenge. Like it was a part of his kind of skill set already. So what became the original challenge was the queuing choice in 2009 was MSMQ, right? Running RabbitMQ on Windows is generally accepted to be a terrible idea. Azure Service Bus didn't exist. And so when we first started, it was MSMQ, and that brought in some baggage around the Microsoft Distributed Transaction Coordinator, the MSDTC. And like, what should we be enrolling in the transaction? Should we not be enrolling in the transaction? And the community just hadn't really decided on a lot of this, especially the Microsoft community, outside of like a dogmatic, yes, use the MSDTC. And .NET had just shipped system.transactions. And so, how do we want to do that? WCF was really in vogue at this time. And so, are we using WCF? Are we not using WCF? So there was some like walking of the landscape that I feel like really had to be done.
Yeah.
And then how do we share the subscription information? How do we get each thing to know about the subscriptions? And so we were like, do we need to build so I think we had like a third party, like another service that you had to run in order to kind of like make everything work. But then the brilliance of RabbitMQ, really, like we found RabbitMQ, and it has the routing is baked into the product itself. So MSMQ was literally, it's just queues. At the time, that was all there was. There wasn't even sub queue support. When RabbitMQ came out, we got 2 new primitives, which was the exchange, which you can think of as the topic if you're familiar with Azure Service Bus, and then the binding of the topic to a queue, which would be what we call a subscription in Azure Service Bus. So with that, like I would say that was probably one of our biggest technical problems, was kind of solved. And yeah, so once that was done, now the problems became configuration and what should the behavior be when, and all of these like very small, important developer experience related decisions.
Yeah, that's fair. And I'm going to ask this one last question.
Bring them all. Let's never stop.
I want to say one last, like for now, before we move forward the conversation a little bit. Samuel is asking as a follow-up, so is there a JavaScript, TypeScript, SDK, or port for MassTransit? Which I guess if we generalize that question, can other things that are not .NET use MassTransit?
So the simple answer is yes. A long time ago, I wrote, like when Node was first coming out, I did write a MassTransit.js. It's since run out of date. Like it's way out of date if you were to find my repo on it. Chris and I were curious about, taking the other stab at it. We did write a MassTransit TS. And that was like us both trying to learn and understand like what all could we do with MassTransit with TypeScript. I have written one for Python. I have written one for Ruby. In the end, you can do it with any language you want because MassTransit is a smart endpoint. MassTransit as a framework gives you smart endpoints and dumb pipes, is kind of to steal a telco reference. Right. So telephone companies, they originally were a very smart network. They would route your network. They would route your phone calls. They provided services via the network. The internet comes around, and now we have these incredibly smart devices on the end of the telco pipes. And we, as a community, have made the telco like a very replaceable service. Like, I don't care if it's satellite. I don't care if it's cable internet. I don't care if it's a phone. All I care about is it's fast and how much bandwidth can it carry. So we made them dumb pipes. And so MassTransit takes that same kind of a concept, and it treats the brokers very, very simply. I need you to get my message from here to there, and I'll take care of everything else.
Right.
So in that end, could you write an integration with Java? Yes, you can. And we've done that and seen that in production deployments where we have a Java process talking to a .NET process. Because in the end, the key sauce is the way that we route things is embedded in the broker. So it's discoverable. So another application would be like, oh, okay, this is what I need to do.
Mm-hmm.
And we have a MassTransit envelope, which just helps with a few odds and ends. So if you use the envelope and you use the headers, you're good to go.
Then you're good to go. So to be clear, specifically when you said you could do that, you're talking about a consuming client, or are you talking about also like a MassTransit server? Like I could write a MassTransit server in another language.
So there is no MassTransit server. And so that's a key point. It's a library that you write your program on top of. And it's closer to like the way Thrift treats HTTP.
Okay.
Or I think there's another one that's a little more popular these days, where Thrift was all of this like policy and control stuff on top of gRPC, if I'm not screwing that up. MassTransit is all of this control and policy stuff on top of AMQP, simplistically, or whatever the broker uses.
Right. Okay.
So the broker, which is the server in this case, the broker becomes this very dumb pipe that gets our data from point A to point B in a very reliable and speedy fashion.
Okay, cool. Yeah, so Samuel, hopefully that answers your question. Again, keep them coming. Keep dropping your questions in the chat, folks. Dru, I want to move forward just a little bit and talk about like patterns, right?
Okay.
So when we talk about like messaging, and for me, MassTransit is not just like a distributed platform, but like it's a messaging platform specifically. And when I think about messages, there's a couple things off the top of my head that I'm like, okay, well, can you do this? So as an example, I think for most folks, the most simple one is like request response. How do I do request response? And then also, how do I like discover where the services are, right? Like, how do you handle like those things inside of MassTransit?
So request response is a fun one, as most messaging infrastructures don't provide it. When you're learning about, at the very early stages of integration and messaging and RabbitMQ, the education is largely that you should be kind of like a one-way communication channel. You should send commands, you should publish events, and then if you need anything, like you listen for it, and it will, like make its way around to you. There's no reason then that the contract couldn't be, if I publish this command that you need, or if I make this request, that you're going to give me this response within X amount of time.
Right.
Now that there's a lot of dragons here in that. What if downstream service is down? What if downstream service is under load? What if downstream service is X? So it's important that if you're doing a request response pattern, that you understand like what happens when it fails. Like you have to really think about what that is, because it might time out on you, but you could still get the response 2 days later because that system was down. So once you get past that, MassTransit directly supports request response. So you can, inside of something that we call a consumer, which you can think of as a controller to map to ASP.NET terminology, you can say, hey, I'm working on this message. And oh, by the way, if this came from somebody requesting it, this is the response I want to give them. And it's a fully realized message of your own construction.
So if we look at the pattern on a high level and not just necessarily MassTransit, then could we say, okay, process A sends a message to process B that's going to respond in some undetermined period of time, right?
Well, we're going to listen for a response and make a decision within 10 seconds.
Okay, got it. Because I was going to ask if the construct was I send the message and then now I'm waiting for the response in the background.
That's another. So we have so there's two request response structures in MassTransit. One is I'm expecting this to happen relatively real time. So it's going to happen in 10 seconds. It's going to happen within, I'll call it an awaitable time. So how long am I going to await it, right? So I'm in my code. I say await, send request. How long am I going to wait for that response? Now, you might have a very long-lived request. Let's say that I want to request some video to be transcribed, and that's going to take a couple hours. Well, I don't want to await for an hour. that's no bueno. So we have this other construct that we call a saga, which is a long-lived transaction. And sagas have a different way of correlating the messages beyond. So in HTTP, right, I open a port to you, and that port is my correlation to you. So any data that comes back is the response, and that's the correlation. With messaging, we end up using something called a correlation identifier. So I can have a persistent entity. We'll just say it's an EF core model, just to get concrete. Right. So when that message comes back, I can use that correlation identifier, which could be anything, to then look up that entity to say like, oh, it was waiting for this to be done. Now it's done. Rehydrate that entity, poke whatever methods and properties I need to on it, and then save it back to the database. And then maybe fire off some more events to say, your download is done.
So it's almost like hey, I fire off like some long running process, like a workflow, right? And then now I'm just in my client application, right? Like in my requesting application, I could just like poke it and be like, what's the status? Like just give me an update kind of thing.
Yeah, and so the idea of status is also a tricky one because again, we don't know if this process is up or down. Right. So we tend to recommend that the working process broadcast updates as events that anything can listen to. And then it's like, okay, cool, this is where it is, this is where it is, this is where it is. And then I'll update my internal tracker.
Okay, so then instead of polling, right? Instead of polling, essentially, like I'll just have another consumer, maybe like a consumer on the requesting side, and that consumer is going to listen to like those events from that particular workflow, that particular stream of execution, to be like, okay, this is where we are, this is what the state of the world is, right? And then now I can react to it on the client side, quote unquote, the client side, to like see what's actually going on.
Yeah. So if you were to draw an activity diagram where you had the arrows going back and forth between two things, there would just be this one arrow going back saying, this is where I am, this is where I am, this is where I am. And if you think about these things as like two human worker processes, you don't want your manager coming over and being like, hey, where are you? Hey, where are you? Hey, where are you? Like, that's not what we want. So you almost want to, at the end of the day, you send off your email, like, this is how far I got. At the end of the day, you send your summary, and now it's done.
Okay. So I feel like sagas more recently, and particularly like workflows, have been like a big topic, at least in the .NET space, right? And I've seen things like Temporal, right? That just released their .NET SDK the other day. I've seen Dapper. Dapper has workflow support. That's in alpha beta, something like that. And we have durable functions. Like we have all of these things, right, that allow us to do like these long running executions, right, that have multiple steps and stuff like that. Like how does the implementation inside of MassTransit kind of think about that? Like is there a particular pattern that it has, or like how does it look at executing like those long running workflows?
All right, Temporal is a great example. There's another one called Ingest, INNGEST, for the Node community. So that's a very specific type of workflow engine that does really fun things with the way the programming language works to achieve what I would call a transaction script. So this is out of either enterprise integration patterns or patterns of enterprise applications. But the idea of a transaction script is I start here, I do this, I do this, I do this, and then I do this. That makes it tricky to kind of like do request responses when there's like a fork in the process. So when it's a simple process that's, like, let me orchestrate these various activities, like they're fantastic. MassTransit, instead of trying to hijack the programming language, so with Temporal, they do it's really cool. They do some really cool things with interfaces. Ingest does really cool things with JavaScript promises. And there's various things like that they're working on. MassTransit takes a much more it's boring in that we're just listening for messages, and we coordinate the messages through the correlation identifier. So if you've ever studied Zipkin or OTel and traces, you'll know that there's like a conversation ID, a correlation ID. There's all these there's like 5 identifiers to make this whole trace work. Like, what's the parent trace? This is the conversation identifier.
Right.
So sagas are all basically tracked around a singular identifier. We normally recommend that you use a GUID, but you can use whatever you want. And when the message comes in, if it defines itself as having a correlation identifier, we can then associate it with that workflow, and then you can walk through and do the steps that you need to do. And we have now this is a spot where MassTransit spent some weird points. We tried to put kind of a DSL inside of .NET that lets you orchestrate a workflow with, when this happens, transition to this state, then do this, and hey, if I'm in this state, ignore these messages because it's too late, you can't do this, they're not allowed, or it's too early. So we have like a state machine also built into it to help the developer deal with the fact that you might get messages out of order. And how do you want to handle that?
Yeah. When it comes to scaling, because I think this could be one of the hard things to do when we think about distributed systems and distributed workflows in general. If I have multiple MassTransit consumer processes, right, and I kick off a workflow, does that workflow execute entirely on one, I guess we can call it a node or one instance? Or
we call them endpoints.
It's just endpoint. So like whoever pulls the message first runs it, kind of thing.
So every endpoint. So let's say that we have, we'll take e-commerce. So just to make things clear, we'll have the side that catches the order from the customer, and then we'll have the warehouse that processes the order. So when I catch the order, I'm going to send a command to the warehouse saying, hey, pick, pack, and ship this to this customer. And so the way MassTransit works is the receiving side defines the name of the queue that it's listening on. The publishing side defines the exchange or topic that it's publishing on.
Okay.
And so they meet via bindings or subscriptions. So when the listener spins up, it's like, cool, my queue name is warehouse or whatever it is. I really care about messages A, B, and C. And I'm the only one that's going to know that I care about messages A, B, and C. So then I'm going to create the bindings to message A, to message B, and to message C.
Okay.
So the publisher has no clue. But the receiver is like, these are the things I'm interested in. And that's how the two meet.
So now what if I have multiple receivers that want A, B, and C, right? Like what if it is the same configured, I don't want to say the same process, the same configuration.
Let's make
like
it
multiple, like it's competing consumers now.
Yeah.
But for sagas.
Let's create a reporting structure.
Yeah.
So the reporting process wants to know what orders are coming in so it can generate a report so that somebody can see that everything's happy. It wants the same data. So we've got a couple of choices here. One is we have to look at what the contract is for when I say, create, like pick, pack, and ship this order. Is it a command? Is it saying, do this? In which case that do this is really defined by the warehouse, because the warehouse has to define, like, this is what you need to tell me so that I can do this. Or is it instead that the order side is saying, I have an order, and it's a broadcasted construct.
Right.
And if that's the agreement, then that contract is defined by the order side, and the warehouse is simply listening to it and getting on with its work. That reporting structure can then come in, and let's say its queue is reporting, and it's interested in messages A, B, and C. So it will also create a binding to A, B, and C, or a subscription to A, B, and C. So any message that's published on A is now going to go to the reporting and warehouse.
Right.
And RabbitMQ takes care of that duplication.
Okay. But what if there's multiple warehouses for load
Are
balancing
they,
perspectives?
is it multiple instances of the same, is it multiple workers for the same warehouse because the volume's very high and we need competing consumer? So warehouse A, I've got 2 .NET processes because JD Edwards is slow, but it can handle multiple connections.
Right.
So we're going to have 2 there on 2 different machines. So if I lose one, like HA, I'm highly available. I keep working.
Yeah.
Or is it that there's 2 warehouses with 2 different ERPs, in which case I need 2 different endpoints, one for warehouse A and one for warehouse B, and they need to look at the message. This is not for my warehouse. I'm going to drop it. This is not for my warehouse. I'm going to drop it. This one's for my warehouse. Let me put it into my ERP.
Right.
And then you get into kind of routing keys and content-based routing, which can add other fun issues. But
yeah, and like our friend Sean. So Sean is a friend of the show. And he made a good point, right? Like it's pub sub versus competing consumers, which is exactly it, right? Like there's I want to broadcast to whoever cares, right? Whoever wants to know about the thing. But then there's also I want to load balance this endpoint because one might be slow, one might be super busy, but I want my throughput to kind of keep going on while while we're doing this work. So I think that's fair. Another thing that I think is important for us to talk about is, in this world of distribution, how does MassTransit look at handling faults? And I guess if we talk about sagas, it's compensations, I suppose, is the terminology that's used in that space. How do I handle when bad things happen? So now I could restart or continue the workflow that we've already started.
So at the most simple layer with just a consumer, if you catch a fault, you're for the most part you just have retries. You have retries and you have deliver later. So retry, you can set a policy in MassTransit that says I want to retry 5 times with an exponential backoff of X starting at X seconds. And so it'll try, it's holding it in memory, it'll try again, it'll try again, it'll try again, and then if it fails, it'll take that message and then dump it into the error queue because that's what you've configured it to do. If I can't process it, I'm not gonna I've tried 5 times, it's not gonna work. I'm gonna get it out of the way because the queue is first in, first out. I'm gonna get it out of the way. I'm gonna dump it in an error queue, at which point someone can come and look at it, figure out what the problem is, fix it, or retry it because now the database is back up.
Right.
So that's the simplest. The next one would be to delay delivery. So it's not working, but it's what is that? HTTP 422, 423, too many requests. Okay, I've overloaded the downstream system. I'm going to delay this message for a minute, for 5 minutes, for kind of whatever. And then I'll try it again. So that's kind of that's the simple stuff. With sagas are ultimately coordinating consumers. So they have, by and large, a lot of the same mechanics. The only thing that's different, thank you, Sean. The only thing that's different is that it can transition to a different state, which means messages when they show up could behave differently. But it's not a net new capability. It's just kind of another way of pushing the food around on your plate. Now, we have another pattern that we call a routing slip. And a routing slip is this idea of, I want to go to service A and do something. I want to go to service B and do something. I want to go to service C and do something. Oh, service C is down. I need to undo this work. So I'm then going to compensate. I'm going to go back to service B and say, hey, please undo that. I'm going to go back to service A and say, please undo that. And then all is right in the world. So an instance of the routing slip would be, okay, I have an order for 5 items. I'm going to go to the warehouse and do I have those 5 items? Sweet, I do. But for whatever reason, the developer, when they built this, put billing after warehouse. Like that was kind of an odd choice, but whatever. That's the way it is. I go to the billing system and I say, hey, charge this card for $50. Credit cards declined. All right, well, oh well. Okay, let me go back to the inventory system. Hey, put that inventory back on the shelf. And I go back to the order system and I say, hey, your order was canceled. At which point the order system may say, all right, well, now you need to go to the customer system and send them an email. And so we've modified the itinerary to add another step. It then goes to the customer system and says, your order's been canceled because your credit card was blah, 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 blah. And that whole distributed transaction process is now complete. And it touched the inventory system, the billing system, and the CRM.
When I looked at the documentation for routing slip, I kind of looked at it as a way to, or one of the things that it does is a way to like alter my path as I'm kind of going through things. So I feel like with sagas, I have like a fixed, well-defined set of steps, right? But then with routing slip, kind of like what you're saying, like, hey, I'm going to look at this message, and like at that point, like I'm going to determine like what my next step is going to be. Like I'm going to determine what I'm going to do next based on like some context within the message that I'm going to look at, you know, the metadata, payload, whatever the case is, right? And like I'm going to be like, oh, okay, you forgot this. Like you said, this didn't happen. Errors happened, right? And now like I have a branch, right? Like I'm going to, that's a bad branch, but you get the point,
I'm tracking.
right? Like,
I'm tracking.
You got to go to different places. And,
we only have so many hands.
Yeah, exactly. But would that be a fair?
Yeah. So
thought?
The routing slip has a core, has two core pieces. One is the itinerary. What steps am I doing? And then, or instead of steps, I should call them activities. So what activities am I doing in this itinerary? And the itinerary is a mutable concept. So as it's going through, I can mutate the itinerary to go do other things. One way that we've seen it used is the itinerary comes into a system and it looks at the customer's current credit score, and it's below a threshold but above another threshold. So they add a step, hey, go get a fresh credit check. So once it's done with that system, it actually goes over to the credit system. It gets a fresh credit check. It updates the data in the itinerary. The itinerary holds a payload as well. And this is where we're using the network as a database, which I'll have to find the link. That's one of my favorite articles ever written. But yeah, so the state is on the network, and it's called network as a database. So when it comes back to my original system, it's like, cool, the credit score is above, it's below. And because it's above, I'm going to add steps 4, 5, and 6. Because it's below, I'm going to add steps A, B, and C. And so we can mutate the itinerary and coordinate or orchestrate, right, all of these services together through the routing slip. And if any one of those fails, each activity has this idea of a compensation of how do I undo it? So this one activity may not need any compensation. It was just a query. Another activity may need to undo some database entries, or it may need to add more database entries because it's an accounting system and you never delete stuff in accounting systems. So I need to append some more stuff.
Right. So would you say like that's MassTransit's way of implementing? So I know a lot of distributed systems folks talk about like orchestration versus choreography, right? Like, would you say like the routing slip is like MassTransit's choreography solution, I suppose, if you want to look at it from that perspective?
Yeah, so the routing slip is the choreography, right? How do I get multiple different systems to move at the same beat? And then, orchestration is I get all these systems kind of doing the same thing. And then I have a terrible time with these words. I keep mixing them up while I'm trying to explain them. The saga, I'll just do this. The saga is I need everybody to like follow the same protocol. It's this. And then the routing slip allows for this like more dynamic, flexible concept of changing things out midstream.
Gotcha. That makes a lot of sense. Drew, I know we're running a little bit late on time. We just got a couple of minutes left, but there's
Uh-huh.
one more pattern that I'd love for us to talk about before we wrap, and that's the outbox pattern.
Mhm.
Now, I've seen transactional outbox, all kinds of outboxes in like different languages and frameworks and stuff like that. Like, I'd love to know, like, what's the problem the outbox pattern in mass transit solves, and like, how do you all kind of go about like thinking about that?
So the clearest outbox, whether it's transactional or not, the problem that outboxes are ultimately trying to solve is on this line of code, you've said you want to publish a message. On this line of code, you've made a change to the database. And on this line of code, you've committed the transaction.
Hmm.
The transaction fails. The message has already been sent. What do you do?
Right.
So that's the core of the problem. What we do instead is programmatically, it looks like you're just saying publish. Just looks like you're just saying publish. Just looks like you're saying publish. And you want to make those publish decisions at the right call site. You don't want to like have to wait till the very end. And many frameworks also don't explicitly ask you to manage the transaction, right? You just go about and do your business, and the transaction is committed for you at the end of the scope. So the outbox allows us to collect those messages, and then once the database has successfully transacted, we then release all of those messages in the order that they were put in.
Got it.
So that's the core problem. Now when we get to a transactional outbox, it's when we say it, what we're really trying to impart is that the messages are persisted in the database. So we're going to take a performance hit because we got to write more stuff to a database table, and that's expensive. And then once we write all the records to the database of like all your data models are written to the database, all the messages are written to the database inside one transaction, we absolutely know it's good. Once that's done, there's another process that's in the background that's going to grab those messages and publish them out because now we know they're good to be published.
Right.
There's another side of this, which is the inbox, like a transactional inbox or some kind of an inbox that's going to say, cool, I have this message. I've taken it off of the broker. It's mine now. And now I'm going to try to run it through the consumer and do all of its work. And I'm going to have all the messages outboxed and then let everything go. And these inboxes can also help you with idempotency because they can provide a window of easy dedupe. Like, I'm going to have my inbox. I'm only going to store messages for an hour, or I'm only going to keep the last 6,000 of them, whatever the configuration is. And then if a message comes in that I've already processed before, I'm just going to ditch it.
Got it. Okay. That makes a lot of sense. So then, like you said, like the whole purpose of that is reducing or trying to completely remove that, hey, I have a transaction, multiple steps in the transactions, two of them fail and two of them pass and one fails. And now, like, what do I do? And that's happening distributed across different machines and not necessarily like on the same machine or the same process, right? Like it's happening in different worlds. And how can I consolidate like the error handling of that?
And just how do I make it easier? Because programming in distributed systems is hard, right? If you can avoid doing this, right? Like avoid doing this. Keep your monolith, keep everything in one thing, have one debugger, you can step through everything, you have transactions. Like, it's building an application that conforms to someone else's mental model is like hard enough as it is without adding all this other stuff in. However, sometimes these are needed. And when they are, there's all of these little patterns that can help you avoid like more complexity down the road, because building idempotent services is just it's hard.
Yeah.
Right.
It is.
And so how can we make it easier? Are there patterns like inbox and outbox, like sagas and routing slips that we can use?
Got it. Well, Chris, this has been amazing, man. Thank you so much, Drew. We are literally out of time now, and I have so much more I want to ask you, but I also kind of want to like obviously respect your time and everyone else's time.
Well, I'm happy to come back.
Well, we're definitely gonna have to do that because I feel like there's so much more we could still talk about. We haven't even spoken about like observability and open telemetry, and like, there's so many other things that we can kind of get into. And I'm sure folks watching have more questions for you as well. But before we do go, I just want to give you the opportunity to, if there's anything going on that you want to share really quickly within the mass transit world, anything with you personally, anything you want folks that have just watched this video to like really go and pay attention to.
The biggest thing is it's an open source project. It's an open source community. I have grown and learned so much through the open source world that come and join us on Discord. We have a MassTransit server. You can join us on Discord. We're happy to help people out. So that's kind of like thing one. The other big thing is this is new. This is relatively new for MassTransit, but we now are offering commercial support. We haven't, for the first 14 years of this project, we didn't offer commercial support. That's a change. That's the thing that's changing. So if you're curious, go to masstransit.io. I think it's like /support.
Yeah, I'm just gonna put it up. Here it is, masstransit.io/support.
So if your company wants commercial support, or that's been a blocker for you in the past with MassTransit, know that that's no longer a blocker. That's a thing that we can do. And then the last thing is more personal, which is I've started to, as I try to figure out how to, to be very clear, how do I capitalize or commercialize on top of all this time I've spent on MassTransit? I have been developing a product that's off to the side, right? It's not MassTransit. I'm not trying to directly profitize that. I have an a sidecar service called MessageAid, or at messageaid.com, which is trying to help people handle when these messaging platforms go sideways. So whether you're using in-service bus, MassTransit, Rebus, Easy, NetQ, Brighter Command, Wolverine, anything, this should help provide a tool and should ultimately take some load off of your operations team.
Got it. And while you were talking, I was just looking up the link for the MassTransit Discord channel. So I'm going to put that up super quick. So for folks that,
thank you.
The link or copy paste it, whatever you want to do. And then you can head over there. And then I also just shared the link for masstransit.io/support. So if folks want to do that as well. And you were just talking about MessageAid. So here's the link for MessageAid. If folks want to go over there and check that out and see some of the cool things that Dru's working on. And let us know. Like, I'm really curious to hear what folks are doing with MassTransit. Feel free to leave a comment on the video. Dru and Chris and everyone else are inside of the Discord channel, so head over there, let them know what you're building. I don't know, do y'all have like a show and tell channel or hashtag or something like that in Discord?
So
is that like a thing?
Chris has a YouTube channel that is at FatBoyG with the PH.
Nice.
And we've done things. So he has some long form content from during COVID. He has some entire 6 hour through 1 hour 1 hour blocks of here's how to build a system with MassTransit. He has a series of things that he calls commutes, which are it's when he is he does a 10-minute, he covers a new feature in MassTransit. And then we also occasionally do something that we call a bus stop, which is when Chris and I get on and just talk about usually something will happen in Discord or something will happen in the larger .NET community or the messaging community that we kind of want to talk about. And so we'll pop on and record a 10 to 20 minute piece.
Got it. Nice. So we just shared the link for that. So there it is at the bottom. Like and subscribe like all good YouTubers do.
Please.
And check out some of the videos that Dru and Chris are doing over there on that channel. But with that being said, folks, I think that's a wrap. If you would like Dru to come back, I know I want him to come back, but this is not about what Cecil wants. If y'all want Dru to come back, let us know. You could see his. There it is. You can see his Twitter link if folks use Twitter.
Oh, it's X, bro.
Or I'm sorry, his X. What do you call it? Your X handle? That sounds weird. Anyway, you can see his handle on social media right there. Follow him, send him a message. Follow me, send me a message. Let me know. Let us know what other episodes you'd like to see, what other topics you'd want to learn about. Mass transit, distributed systems. Maybe you want to talk more about patterns and messaging formats and serializations and all these types of things. All that's open game. Let us know. But with that being said, thank you all so much for being here. Really, really appreciate you folks. Sean wants you to come back, so I think that's it. We only need one vote, so that's it. Sean wants you to come back, so you're gonna come back. We're gonna work that out. But yeah, thank you all very much. Thank you for being here. Thank you, Dru. And yeah, we'll talk to you all soon.
Thank you.
Bye, everybody.